In this video, we're going to start to use integrals inside the applications of business. Now, as we discussed before, derivatives show up in business mainly due to the fact that when you have a total quantity, the derivative of that total quantity or function is the corresponding marginal quantity or function. Alright, so that means that if I want to find a total function given the marginal function, I'm going to have to integrate it back up or take the antiderivative. So, for example, let's pretend that the marginal revenue for my company is equal to the function negative 0.3x plus 400. All I have is the marginal revenue. For some reason, I was only able to keep track of the marginal quantity. But can I still find out some things about that total quantity? Can I find the total revenue function? Well, yes. Just as the derivative of total revenue is equal to marginal revenue, same thing as saying the integral of marginal revenue is equal to total revenue. So I can find the total revenue function by taking the integral or antiderivative of the marginal revenue function. Now once I have that function, I can answer the question, what is the total revenue when I'm selling 40 items, when x is equal to 40? Okay, so all we have to do is say the total revenue function is going to be equal to the integral of the marginal revenue function, so we can see how important the integral concept is going to be. Alright, now from what you've studied so far, these are all powers of x. This is a polynomial. You should be able to get that indefinite integral. What's the answer right there? Well, let's see, that constant multiply, might as well just pull that out so it doesn't confuse me. And then I can split these up into two integrals because of the sum rule right there. So if you like, you can see the question as this. And of course the integral of x is x squared over 2. So that's going to be the first term right there. And then the integral of 400 is 400x. And then don't forget, there's always a plus c term right there on an indefinite integral. Okay, so the answer is negative 0.3x squared over 2 plus 400x plus c. Plus c. Now, if I'm going to answer a question like what is the total revenue at a point, I can't be having a plus c term floating around because that could really make a difference depending on which c I use, right? So actually, it's not proper for me to have a plus c in my answer right now when I'm trying to answer what is the total revenue. In order to get rid of the plus c, I need one value for the total revenue function to solve out for the plus c, to solve for c. Okay, this is also known in some books as an initial value problem because when you integrate a function up, you always end up with the plus c. But in order to get rid of that plus c and pinpoint exactly what function you have, you need to have at least one value for the r, and then you use that value to solve for the c. I'll show you how that works, but first, let's think about what value we could have for r. What I'm saying is, I just need 1 point on the function r of x. Like right now, my function r of x, it looks like this, or it looks like that, or it looks like that, or it looks like that. The plus c says that it's in the rainbow of functions here, which are all vertical translations. Which one of these functions out of this function rainbow am I supposed to pick and say that's actually my revenue function? Do I have any idea what the total revenue should be at any given point? Like for example, if I had 0 items, if I sold no items at all, how much total revenue should I get? 0, right? I'm not going to make money if I don't sell anything. So actually the one value that I definitely have, and this only goes for revenue function, it doesn't go for cost or profit. For revenue, I always have r of 0 equals to 0. This is always true. Why is that always true? Well, because how are you going to make any revenue if you didn't sell any items? If you don't sell any items, you should make exactly $0, and so r of 0 is equal to 0. Now, with this fact right here in place, the fact that r of 0 is always equal to 0 for total revenue, I can finally see what my function is on my family of rainbow functions here. It must be the function that goes exactly through 0, 0. That's the only way that I can go about it. I have to pinpoint one of those things, and it's got to be the one for a revenue function that goes through 0, 0. Now that's really nice, because once I have that in place, then I'm going to be able to solve the question, what is the total revenue function? Now I'll show you how I solve out for the plus c at this point, given the information that r of 0 is equal to 0, and the fact that r of x is equal to negative, I'll write it like this, 0.3 divided by 2 is 0.15, x squared plus 400x plus c. I also know that r of 0, which is going to be this function plugged in when x is equal to 0, has to be equal to 0. That's why I need the point. As soon as I have that point, also known as the initial value, then I can use that initial value and plug it right in, and the only thing that's going to be left when I plug in a number for x is that the only thing unknown left is going to be the c. And so this always leads me to an equation that solves it for c. In this case, I just get the fact that c is exactly equal to 0, and so I can make my conclusion that my total revenue function is negative 0.15 x squared plus 400x, and it's no longer plus c, because I solved for the fact that c is equal to 0. Okay, so that's perfect. So that's the answer to what is the total revenue function. It's equal to that function right there. And then to answer the question, what is the total revenue when x is equal to 40, then, since I've already solved for the plus c, I can simply plug in the number 40 right there and multiply it by all that stuff, and you should get the number $15,760. So that's the other answer right there. Oh, the power of integrals. They're so, so useful. Let's do one more example problem. And in this one, I'm going to give you the derivative of an average cost function. And then I'm going to give you some information, 1 point of the value of the average cost function. And I'm going to ask you to give me the functional form of average cost. Okay, so for the final example here, let's say that the average cost function's derivative, the derivative of an average cost function, is going to be equal to 1 over 4 minus 100 over x squared. Okay? Now if I asked you, what is the average cost function when you know the derivative equals this, you would have to integrate it. But when you integrate it, you're going to get a plus c. And what are you supposed to do about that? This is not enough information to answer the question, what's the average cost function c bar of x? That's not enough information. How am I going to solve for the plus c? So you have to give me a point. So I'll tell you that the average cost when x is equal to 4 is $56 per item. Remember that an average cost function is generally in the units of dollars per item. And so this is exactly the point that I need. This right here is going to give me information about what c bar is, and this is what's going to help me solve for the constant of integration. This is known as the initial value. Okay, so let's dive into this problem. First things first, I want to integrate the derivative, and if I'm going to integrate, I should probably rewrite all the x's on the bottom in terms of the x's on the top with the negative powers. That's going to help me to figure it out when I have to add 1 to the powers, right? Okay, so I'm going to get this dx, and that's going to give me the c bar with the plus c. Okay, so go for it. Right, so the 1/4 goes to 1/4 x, and then this is a tricky one. Minus 100x to the minus 2. What did you get from that? Let's see. Well, x to the minus 2, when I add 1, goes to x to the minus 1, right? Minus 2 plus 1 is 1, right? And then the minus 100, well, if I put a plus 100 here, you can see that if I take the derivative of this, the minus 1 comes down, and it makes this a minus 100, which is what I have. And then the x will go down by a power to make a minus 2. Keep in mind that no matter which way you prefer to obtain the antiderivative, whether it's using the power rule directly or making a guess, you can always check your answer at this stage by taking the derivative. So once again, the derivative of 1/4 x is 1/4. The derivative of 100x to the minus 1 is minus 100x to the minus 2. Check. You should always check right at this stage before moving on to the last part. And the last part is I have to use to find the plus c term. Okay? I don't want to give this answer with the plus c because I can't just tell you the answer is like, plus or minus an arbitrary amount. That would be ridiculous. So now I have to solve out for the plus c. The fact of the matter is that my c bar value when x is equal to 4 is equal to 56. That's equal to 56. Well, what is the function equal to when x is equal to 4? It's equal to 1/4 times 4 plus 100 times 4 to the minus 1, okay? And that's really the same thing as taking 100 and dividing it by 4. So that's equal to 1, because these cancel to 1, plus 25. Oh, sorry, I forgot the plus c. So really I should be writing right here plus c. And that's 1 plus 25 plus c has to equal 56. Okay, so do you see how I'm taking the initial value that I must have been given and using it to help me find what the value of the constant of integration is? So that's the 1. This term right here turns out to be 25. And then 1 plus 25 plus c equals 56. So since this is 26, I'm just going to minus 26 over here. And I'm going to get c equals 30. Now I can answer the question. I can't have any funky plus c's floating around in my answer. The official answer is that my average cost function is 1/4 x plus 100 divided by x, or you can write that as 100x to the minus 1, and then plus the constant that I solved out for, which is plus 30. All right, that's great, that's great. Actually, I have just one more quick example to show you this one more time. And this is hopefully what's really useful to you because you can see now how this directly applies to the analysis in business. Let's say I've got one more question. Let's say I have my marginal cost function. The marginal cost is equal to 3 plus 0.2x. All right? And this marginal cost function is in dollars per items. Find the total cost function. Well, you're going to have to give me more information. Let's say the fixed cost for my business is $1,200. Okay, this is the statement right here, similar to this statement over here, that's going to allow me to solve out for the plus c. Okay, the fixed cost is $1,200. Now find the total cost function. I just switched colors because my black pen was running out of ink. Go for it. Go ahead and solve this one out. Okay, so in the first part of the setup, we have to integrate the marginal cost to get it back into total cost lands. And when we integrate that, it seems like we get 3x coming from the 3, and we got 0.1x squared coming from the 0.2x, and of course, there's that plus c right there. Now, before I solve for the plus c, I want to make sure that I'm right so far. As soon as you integrate a function, you should stop and then check it. Stop right here, take the derivative, and make sure you get what was asked for in the integrand. The derivative of 3x is 3. The derivative of 0.1x squared is, the 2 it comes down, so I get a 0.2, and then x to the 1. Checked. Make sure you check that out first so that that error doesn't propagate through your answer. Okay, so I've got this answer so far, and then it's got the plus c. Now, what is this sentence trying to tell me right here? When I tell you fixed cost is equal to $1,200, what does that mean? C of what is equal to 1,200? How many items is that? Well, what fixed cost is means if I didn't make any items at all, if I made 0 items, my cost would still be $1,200 because I have to pay that fixed cost no matter if I make items or not. So what this is really trying to tell me is that capital C of 0 is equal to 1,200. Okay? Oh, and that reminds me, don't get this capital C confused with this capital C. It's unfortunate in this class that we've already reserved the capital C for total cost, but Mathland has also reserved the capital C for the constant of integration, so these are just a coincidence. These do not have anything to do with each other, this letter C. Okay, so anyway, I need to figure this out. So I'm going to say that C of 0 is equal to this function when I plug zeros into it. So I'll just plug in 0 like that, and then there's that plus C. And that's supposed to equal 1200. And since I have zeros here and zeros here, my conclusion right here is that my constant of integration C is equal to 1200. And that allows me to conclude that my total cost function, C of x finally, is going to be 3x plus 0.1x squared plus 1200. And if you've been studying cost functions a lot, you see that fixed cost is often the part that has no functional x dependence. So the constant right here has always represented fixed cost, and so it makes sense to see that 1200 right there. Okay, so when you're going from marginal functions to total functions, you only need to integrate up the marginal quantity, but you must also have one value that you can pinpoint in the total quantity so that you can solve for the constant of integration.